Today we are going to start a new chapter of class 12. Here we have the first chapter, which is electrostatics. And the first question is, calculate the charge carried by 12.5 into 10 to the power 8 electrons. Now, we know from the quantization of the charge, Q is equal to N into E, where Q is the charge, N is the number of electrons, and E is the charge of the electrons. And we know the charge of electron E is equal to 1.6 into 10 to the power minus 19 coulomb. This is the value of E. And in the question, the given data is, so the number of electrons is given, which is 12.5 into 10 to the power 8. Okay. Now from this equation, now we can write, so Q is equal to N is 12.5 into 10 to the power 8 and E is 1.6 into 10 to the power minus 19 coulomb. Okay. So 12.5 into 1.6, it will be 20 into 10 to the power minus 11 coulomb. Or we can write it as 2 into 10 to the power minus 10 coulomb. So this is our answer. So Q is equal to the charge carried by 12.5 into 10 to the power 8 electron is 2 into 10 to the power minus 10 coulomb. Question number 2 is, how many electrons would have to be removed from a copper penny to leave it with a positive charge of 10 to the power minus 7 coulomb? Okay, so the charge is given, so Q is equal to 10 to the power minus 7 coulomb, and from quantization of charge we know that Q is equal to N into E, where N is the number of electrons and E is the charge of an electron, and we know the magnitude of electric charge is 1.6 into 10 to the power minus 19 coulomb. So from this equation we can write N is equal to Q upon E. Now the value of Q is 10 to the power minus 7 and the value of E is 1.6 into 10 to the power minus 19. So it would be 1 by 1.6 into 10 to the power, this would be plus 12. Okay, so this is 6.25 into 10 to the power 11 electrons. So this is our answer. So 6.25 into 10 to the power 11 electrons would have to be removed from a copper penny to leave it with a positive charge of 10 to the power minus 7 coulomb. Question number 3 is, calculate the charge on an alpha particle. Given charge on a proton is 1.6 into 10 to the power minus 19 coulomb. Okay, now we know the charge on a proton is given. So, okay, we know that an alpha particle has 2 protons and 2 neutrons. And we know that all atoms or all particles have equal number of protons and equal number of electrons, right? So 2 protons mean 2 electrons. So we can write, that means the charge of an alpha particle is 2 into electrons, right? And that should be positive. Okay, that means 2 plus 2 into 1.6 into 10 to the power minus 19 coulomb, which is equal to 3.2 into 10 to the power minus 19 coulomb. So this is our answer. So the charge on an alpha particle is 3.2 into 10 to the power minus 19 coulomb. Okay. Question number 4. Calculate the charge on 26 Fe nucleus. Given charge on a proton is 1.6 into 10 to the power minus 19 coulomb. Okay, so In 26Fe56, it has 26 protons and 26 electrons, and 56 minus 26, which is equal to 30 neutrons, right? And from the quantization of charge, we can say Q is equal to N into E. So that means it is plus of 26E. So now just substitute the value of E here, which is plus of 26 into 1.6 into 10 to the power minus 19 coulomb, which is equal to 41.6 into 10 to the power minus 19 coulomb. This is our answer. So the total charge on 26Fe56 nucleus is 41.6 into 10 to the power minus 19 coulomb.